Alright, before we do problem number 6, I will show you my main course. This is my main course. It is chicken enchiladas and mole. Trace of them, 3. There's whoa. There's 1. There's 2. There's 3. There's my beans and cheese, and there's my arroz. Rice. And there's some cabbagey stuff right there. And I ate this all with chips. Of the 3 things I got, this was absolutely the best. The 2 things in the beginning weren't that good. Lost you. This was decent. I really love chicken enchiladas in mole sauce, but I haven't really been able to find a really good one out here. So if you know a place that has really good enchiladas and mole, please let me know. Let's do problem 6. Let h of x be defined as f of x divided by g of x. It's a piecewise function. It's a piecewise rational function. So we're given the 2 graphs of f and g, and we need to piece it together. So identify the values where h of x equals 0. If h of x equals 0, we are talking about zeros of the function, x-intercepts. So when will a rational function equal 0? Well, it will equal 0 when the numerator equals 0. So we can just look at the graph of f of x and determine when that is equal to 0. That's 0 at -2 and +2. So h of x will equal 0 when x equals plus or minus 2. State the domain of h of x. Well, first off, notice that it goes from only -3 to +3. It's a piecewise function. It doesn't continue on forever. So it has to be between -3 and +3. So what's the other thing we need to think of and be careful? Well, we need to remember that this is a rational function, which means we have x values in the denominator. G of x is in the denominator, and we know that you cannot divide by 0. So if g of x is equal to 0 anywhere, we cannot include that x value in our domain. And look, we have a 0 on g of x right there. So we know that the x value 0 cannot be included in our domain. So I'm going to write it down here just because I'm writing big. We're going to say x in R such that -3 is less than or equal to x is less than or equal to +3. And we also know that x cannot equal 0. Interval notation is a little more straightforward, or maybe more annoying. I don't know. We'll see. X is in the interval going from -3, including it, up to but not including 0, union with 0, not including it, up to +3 right there. Those 2 things say the exact same thing. If you wanted to, you could be fancy schmancy and say x in R such that the absolute value of x is less than or equal to 3, and x is not equal to 0. Those 3 things there all mean the exact same thing. If you use absolute value of x is less than or equal to 3 like that, I'll give you a high five because I think that's the sweet way to do it. It's the most efficient way to do it. I don't know, maybe interval's more efficient in this case. Whatevs. There we got it. Let's do C. Evaluate g of f inverse of 1 plus 2. Or I should say g of f inverse of 1 plus 2. Okay, well, what do we need to figure out? We need to figure out what is f inverse of 1. So that 1 right there, what is that? Well, that is a y on f. So go to the graph of f, it's that parabola there. Find the y value of 1 right there. Use the corresponding x value. X value is 0, so this becomes g of 0 minus 2, which of course is just g of -2. So that -2, that is an x value on g. So where's the x value? G, -2. What's the y value? And the y value is 0. So that is 0 right there. Lots of stuff to fit on the screen, but there you have it.